Here in this video, we're going to look at parallel and perpendicular lines. And if we start off by looking at parallel lines, of course we know that there are two lines that are never going to cross each other. And we want to look at kind of the relationship of parallel lines and their slope. Well, if we think of the slope here as your rise and your run, then what do you think the rise and run for this line would be if it's going to be parallel? Well, a little bit of logic and a little bit of common sense here would tell us that if these lines are never going to cross each other, they must be going at the same angle, so they must have the same slope here. So if we have lines that are parallel, then if this is, we'll call this line 1 and this one line 2, then if they are parallel, then the slope of line 1 has to be equal to the slope of line 2. So parallel lines will have the same slope. Now, what about perpendicular lines? Well, if we have perpendicular lines, that means that we have two lines that cross at a right angle. So here's two lines that cross at a 90-degree angle. And if we want to compare the slope of, let's say, line 1 to line 2, then they're going to be the negative reciprocal. Okay, so the slopes are going to be the negative reciprocal. And what that means, for example, if we say that the slope of one line here, let's say that we have the slope of is equal to, let's say, 2/3, and if it's going to be perpendicular, then the slope of the line that's perpendicular would be the negative reciprocal. So the reciprocal would be 3/2. That's where you simply flip the fraction, and we're going to take the negative of it, so it'd be a negative 3/2. So here 2/3 and negative 3/2 would be the slope of perpendicular lines. Whereas over here, if we had, say, 2/3 is our slope, and if the slope of the other line is also 2/3, then we know that they're going to be parallel. So let's see if we can identify our lines that are going to be parallel or perpendicular. So if we're given, say, line 1 has the equation, let's say, negative 4x plus y equals negative 1, and line 2 has an equation negative 4x plus y equals 7. And from looking at the equations here, we want to be able to determine, are these lines going to be parallel, perpendicular, or neither? Maybe they just intersect. Well, if we know the slope, we can determine if they're going to be parallel or perpendicular. Well, remember we talked about the slope-intercept form. So if we rewrite each equation in slope-intercept form, which means we're going to simply solve for y. So if we solve the first one for y, we need to get rid of the 4x. So we're going to add 4x. So we get 4x minus 1. And then over here, if we do the same thing, we would have y equals, add the 4x, we get 4x plus 7. So if we compare the slopes, we have here a slope of 4, and over here we have a slope of 4. Now, because these slopes are the same, then we know that they're going to be parallel. Okay, and then of course we have the y-intercept here is negative 1, the y-intercept over here is positive 7. Now I think this question should be pretty obvious, but let me kind of give you an example here. What would happen if we had y equals 4x minus 1 and we had y equals 4x minus 1? Well, if you compare the slopes, you would say, well, we have the same slope, the lines must be parallel, but if you compare the y-intercept, they're the same as well. So here, the equation here of these two lines would actually be identical. They're the exact same line. So be careful. If the slope is the same, but also the y-intercept is the same, then you have exactly the same line. All right, let's try one more example. Let's say that we have the following two equations. For line number 1, we have y equals a negative 4/5 x minus 5. And for line number 2, y equals 5/4 x plus 1. And again, the question is, are they parallel, perpendicular, or neither? So if we compare the slope, well, it's already in y equals mx plus b, so we know the slope of the first line is a negative 4/5, and the slope over here of the second line is 5/4. So if we compare, they are going to be the negative reciprocal, so therefore they would be perpendicular. Now, there's one other way that you can actually compare the slopes to see if they're perpendicular, and that is if you take the two slopes, which is a negative 4/5, and you multiply the two slopes together, what do you end up with for an answer? Well, if you notice, what's going to happen is 4 and 4 cancels, 5 and 5, so you're left with simply a negative 1. If you multiply your two slopes together and you get a negative 1, that means that they're a negative reciprocal of each other, which means they're going to be perpendicular. So that's another kind of little trick you could use to determine whether the lines are going to be perpendicular or not. All right, the next example we have here is probably a pretty famous question that you've seen before. It says they want us to write the equation of the line through the given point. Okay, so the given point is negative 3, 2, parallel to the given line, which is x plus y equals 7. So let me kind of sketch out what they're asking for here. They tell us that we have our given line is x plus y equals 7, and our given point is negative 3, 2. We want the equation that goes through the point negative 3, 2. So let me kind of draw this out. So if we find the point negative 3, 2, that means we're going to actually go over 3 and up 2. So there's our point at negative 3, 2. So we want to find the equation of the line that goes through this point, but so that it is parallel to this given line x plus y equals 7. Well, let's graph x plus y equals 7. Well, how can we do that? Well, if we solve for y, we get y equals negative x plus 7. Now, what do we know about the slope of this line? Well, we know the slope is going to be equal to negative 1. Now, if we're looking for a line that's going to be parallel, what do we know about the slope of parallel lines? Well, we just said they're going to be equal. Well, let's go ahead and now they don't ask us to do this, but I want to kind of give you a little bit better visual of what we're doing here. Let's go ahead and graph this equation here, y equals negative x plus 7. Well, the 7 is our y-intercept. So here we have 1, 2, 3, 4, 5, 6, 7. So we have a y-intercept here at 7. And then our slope is a negative 1. So that means we would go down 1 and over 1 to find another point. So if I go down 1 and then to the right 1, we have another point. And this is going to give us our line. Now, what we're asked to find here, this is the given information. Our given equation, y equals negative x plus 7, which is this given line here in green. We want to find the equation of the line that's going to go through this point, negative 3, 2, so that it's parallel to this given line. So I'm just going to kind of think, well, we want to find the equation of this line here. If I draw a line through here, these two lines look fairly parallel, but we want to come up with the equation of this line. Now, if you think back to the other videos, what did we have to find if we're trying to find the equation of a line? Well, there's two things, remember, we need to know. We need to know the slope, and we need to know a point on the line. Well, obviously, we know the point. They give us the point is negative 3, 2. So we have the point, negative 3, 2. So I'm going to write this down. We have negative 3, 2. What else do we need to know? We need to know the slope of the line. Well, if this line is going to be parallel to the given line, the slopes are going to be the same. So the given line has a slope of negative 1. So that means we want to use the slope of negative 1 because, again, here we're looking for a line that's going to be parallel. So now we're going to do the same thing we've done before. And if we want to use y equals mx plus b, or you could use the point slope, we would plug 2 in for y, so 2 equals our slope, negative 1 times negative 3 plus b. So that's going to be negative 1 and negative 3 is 3. So if we have a positive 3, we have 2 equals 3 plus b. So that means b is equal to a negative 1. So therefore the equation would be y equals, what was our slope? Negative 1. So that's negative x minus 1. So y equals negative x minus 1 is the equation of the line that is parallel to this given line. Now we can kind of verify that. We have y equals negative x minus 1. Well, negative 1 is the y-intercept. So here's our y-intercept at negative 1. And we already have the given point, so we can certainly just connect the dots. And our lines are going to be parallel. All right, now, the second question that we have here is we want to write the equation of the line through the given point. So once again, we still have the given point, which is this same point here, negative 3, 2. But now we want it to be perpendicular to the given line. So that means we're going to go through this line, but it's going to be perpendicular. So roughly we're looking at something like this so that it makes a right angle to our given line. All right, so how do we do that? Well, if we're looking for a line that's going to be perpendicular, we already know the point. What are we going to use for the slope? Well, remember the relationship for our slope. We said for perpendicular lines, we're going to have this negative reciprocal relationship. So if our slope of the given line over here is negative 1, if we take the reciprocal, that's just going to be 1 over 1, so it's still going to be 1, but then we're going to change the sign, so instead of a negative 1, it's going to become a positive 1. So I want to make sure we realize if this is our slope, our given slope is negative 1 over 1. Well, if you take the reciprocal, you're still going to get 1 over 1, but now it's going to be positive because we're going to take the negative of it. So now we could use our same y equals mx plus b. Our y value is 2, our slope is 1, so that's 1x, or 1 times x rather, sorry. That'd be 1 times our x, which is negative 3, plus b. So we have 2 equals negative 3 plus b. And if we add 3 to the other side, our b value turns out to be 5. So we would have y equals mx, so that's 1x, plus b, which is 5. So y equals x plus 5 is going to be the equation for our perpendicular line. And once again, the 5 is our y-intercept. So if we count 1, 2, 3, 4, 5, here's our y-intercept. And if we draw the line through here, we do have a line that's going to be perpendicular. So really, all that we had to find here is if they say that you're looking for a line that's parallel, just keep in mind that you're going to be using the same slope. But if you're looking for the equation of a line that is perpendicular, you're going to have to use the negative reciprocal. So then once you have the slope, you use the point, and it's the same thing we've done in the previous examples. So once again, with parallel lines, you're going to have the same slope, and with perpendicular lines, you're going to have the negative reciprocal.